Well, let's discuss pointers today. We'll start with the basics. So the pointers. Okay. The thing is, whenever you store a value in a memory, the memory block in which you store the value has a thing called address for identification of the location of the memory. Now let us consider you have stored a value int. Let's say you write this statement int a is equal to 15 in your code. Now the value 15 is stored in a memory block which you named as a. Now in the whole big memory of the CPU or RAM or cache, how do you identify the location A? So for this purpose, there is a thing called address where you can access the value of A through the address of the memory block A. Now let us consider the address of this memory block is 120. Fine. Okay. So the basic thing, let's discuss an operator called address of operator. Address of operator denoted by AND. So what this thing states is address of memory location A. Address of memory location named A. Well then, pointers. Pointers are used to store the address of memory locations. The basic thing is to store the address of memory locations for our calculation purposes. There is address assigned to each and every memory block, but for our calculation purposes, where we have to get to the address, we use pointers. So pointer points to the memory address of the block with which we are concerned. Now, what's the syntax of writing pointer? It's int star p equals and a. Now, what does this statement states? This is a normal protocol to initiate any pointer. This simply states that a pointer named p which points to the integer class is created. Fine. Then this, as we already discussed, this says address of memory location named A. So then the total statement represent we have created a pointer which has value or which stores the address of A. So how does this statement looks like? It looks like this is your A, which is address 120. You have created a new pointer which stores the address of this. So the value of this is 120. Of course, it may have some another address of itself. So this is the basic thing. When you want to access A, you access it through the pointer, through the address of A. Now then, we have yet another operator called the dereference operator. Dereference operator denoted by star p. What does it take? It gives the value of address stored at p. Value at address stored at p. Basically, consider our previous example. Now, when you write and p, in this case you get 104. When you write p in this case, you get 120. Of course the address values are in hexadecimal always, but for the simplicity and for our understanding we have taken the value as 120 and 104. Now when you write dereference p, what does it say? Value at address stored at p. What is the address stored at p? 120. You go to 120. What is the value at 120? 15. You get the value as 15. So this one is called dereference operator. Then again we wrote here int star p. We can write char star p is equal to again and b. It points to the address of memory block which is of type character. Fine. Again you can write double star p is equal to, and it points to the address of the memory block of name d and of the type double. Fine. So let's talk about the size of pointers. Int has 4 bytes generally, double has I guess 8 bytes, and so the point so does the size of pointer varies according to the data type to which it points? No, because look, the basic thing about pointer is it stores addresses. Now the address of memory block has a fixed thing, right? It doesn't depends on like for the int the value, the size of the value increases or like that. So the size of pointer always remains same because it has no relation with the type of data with which we are concerned and we are pointing to it. Fine. Then so the size of pointer always remains same. This is the basic thing and an important one thing. Okay, then let us say you just wrote int star ptr. This is a very bad practice because it will point to some garbage value and you won't be able to track it in a good way. Suppose you did write it 0 to 0. Now what does it convey? It conveys the pointer points to null, that is no memory location. And suppose you updated it as like this will give you a segmentation fault. Now why is this? Because the pointer already points to the null memory location. It basically states that the pointer is pointing to such a memory location which doesn't even exist, and hence you are bound to get segmentation fault. But just a second. Sorry, my bad. This will be fine. We will be fine with this thing. But suppose we didn't update it and I just say directly. Now this will give segmentation fault. Because it doesn't point to a valid memory location. and it will not generate any value. But we can write int star ptr is equal to 0, and then you update ptr with the address of I. This is fine. This should be fine. Then there is a thing like copying pointers. How do you copy the pointer? Suppose I created a pointer which references, which stores the address of n. Then I create another pointer which just stores p. Now, how do you what does it represent? There is a memory location with name n, and your pointer p points to the memory location a. Your q has copied p, hence it also points to the memory location a. So this is the meaning of this statement. Fine, then let's move on to a thing. Consider your pointer int star t is equal to n, and then you write the statement as star t plus plus. What does it state? The value stored at the address of t. The value stored at address at t, which is updated. Now what is the value stored at address stored at t? It is the value of n. Suppose n is 3. Now n is updated to 4. Now when you print n, it generates 4. But suppose you write this statement: t is equal to t plus 1. Now what is t? T is an address. When you talk about address, you just updated the address. Suppose t used to point at this location. Now it points to the block next to the thing. Now how does it reflect in the numbers of the address? Suppose this is memory location 100, then this must be 104 considering int, because the int occupies 4 bytes. So when initially, if the value of t would have been 100, now it is 104. So the value increment is equal to the number of bytes required by the int, and it points to the next memory location. Now it doesn't point to the previous memory location of n. So this was the basics of pointers. We'll discuss next things in the next one.